Hello, so this video is going to talk about an introduction to the concept of what a function is and how to evaluate them. We will get into much more complex details of functions in the Algebra 1 course, and as well as further beyond that, so don't expect too much right off the bat. So a function is a relationship between an input and an output. There is exactly one output for each input. You will generally, so for example, one way to look at them is with ordered pairs, kind of like if you were to plot on a graph. So the key is if you see, all ordered pairs are considered a relationship, a relation, but only certain relations are an actual function. I take this one for example. Our input is the x value, and the output is our y value. So the key is to make sure our x values, our inputs, are never repeated. I'm allowed to repeat outputs, that's fine, but I cannot repeat an input and still have it be a function. So I have 7, 3, -2, -1. They're all different. So this is a function. For this one, we have 5, 3, 6, 3. I seem to be repeating these two x values. Because I've repeated my inputs, this is not considered a function. And then now for this one, 4, 1, 6, -3. None of the x's are repeated. I did repeat y's, both 7s, but that's okay. As long as I don't repeat the x values, it is still a function. Another way to look at this is generally when you see graphs, you have your function. Let's say this is our function right there. This would pass what we call the vertical line test. The vertical line test is if you were to draw a vertical line through any part of the graph, as long as it does not intersect the graph in more than one place, it is a function. So if you think about something like this, your x values are both 3's, you'd plot those 2 points. Like if I had to plot these, we have 5, -8, so it's like here. 3, 4 is like there, 6, -2 is like here, and 3, 1 is like there. If you notice, they're both vertically. If I draw a vertical line through them, it goes right through them. That's another reason. That's a way to look at it with the vertical line test, at least. Now, when we talk about evaluating functions, this is where you're going to mainly see a lot of your functions, either evaluating them or graphing them. And we'll get to graphing much later. Function notation is generally used with the f of x symbol. It's not f times x, it's considered f of x, is how we say this. Though any letter can replace f and the x, like it's not uncommon to say g of x, h of x, k of x, r of y, q of z, stuff like that. For the most part, though, you would generally see f of x as your go-to function notation. In higher mathematics, we use different symbols for it, simply because they're meaning different things. So for example, this would be a function. F of x is 3x minus 5. X is our input, and when I plug in an x value, I evaluate my function, it's going to give me a y value, our output. And to evaluate it, like for example, to evaluate f of 4, you would simply replace the x in the function with that number 4. Pretty much whatever is inside this parentheses right here goes wherever the variable is right here. So if it's f of 4, we would do 3 times 4. Minus 5, which is 12 minus 5, which is 7. So whatever is inside the parentheses, whatever number or expression, would go and replace the variable that is normally inside the parentheses. So for example, we're going to do all of these function evaluations based off f of x equals 6x plus 3. So f of 4 again. So we would do, since the x is now replaced by the 4, I replace all my x's with 4. So 6 times 4 plus 3 becomes 24 plus 3, which is 27. So the value of the function at 4 is 27. F of -2. Well, again, the x is being replaced by a -2. So 6 times -2 plus 3 is -12. -12 plus 3. I have no idea why that just deleted. There we go. Which equals -9. F of 0. 0 is still a number, so we still replace the inside x with 0. 6 times 0 is always 0. And 0 plus any number is just that number. This 0 situation right here, when we talk about graphing, is really important. We'll get into this. Trying to remember this term. This is what we will call, for a linear function at least, the y-intercept. And again, we'll get to that in terms of linear functions at least at a much later date. f of 3y. So now I don't have a number, I have an actual monomial variable expression. The concept doesn't change though. All these previous problems, I replace all my x's with the number inside. 4, -2, 0. So I'm going to replace it with 3y. So we have 6 times 3y plus 3. Well, I can multiply a variable with a number. That's allowed. I just can't add them together. So 6 times 3 is 18. So this is 18y plus 3. Now again, these can't combine, so that's as far as it goes for evaluating this function. Even more complex, though the same rules still apply, we have f of 4z minus 2. Now I don't have a number. Now it's not a monomial. This is a binomial expression. But the same rules still apply. So we can do 6 times whatever is on the inside. 6 times 4z minus 2 plus 3. So now we're going to have to use what our distributive properties tells us to do. 6 times each number on the inside. So 6 times 4 is 24. 6 times a -2 is -12. And now I need to combine my like terms. Well, I don't have any z's. Still 24z. And the -12 plus 3 is a -9. So the final simplified version is 24z minus 9. So that's how you evaluate functions. Whatever is this, the initial function will tell you exactly what the variable is, f of x, g of y, whatever. And it'll give you the variable in the expression. And when you have a number inside the parentheses instead of a variable, you replace the variable with that number. If you have a monomial inside the parentheses, you replace the variable with that. If you have an expression, replace the variable with the expression. So why don't you go ahead and do these three based off the function g of x is -2x plus 5. So you're going to do g of 1, g of -4, and g of 3y minus 2. So go ahead and pause the video so you can evaluate those, and then I'll give you the answers in a little bit. Alright, your answers for the first one is 3, 13 for the second one, and -6y plus 9 for the last one. Okay, so again, I believe that is, yep, that one is it. So again, as usual, if you have any questions or comments, please leave them for me. If you want to talk to me personally, just contact me directly. And again, as always, keep them appropriate. See you next time.